Hello, welcome to our lesson on section 7.5 from our trigonometry course. In this section, we're going to be talking about the sum and difference formulas for sine, cosine, and tangent. So our main goal here is to help you understand, given a problem, how to pick the appropriate formula and then apply it correctly. Our first example that we're going to start with says tangent of 15 degrees. They want us to find the exact value, okay? So the first step is to notice that we are going to be using one of the two tangent formulas where alpha and beta would be two angles from the unit circle. So here the goal is to come up with two unit circle angles that either add to make 15 degrees or subtract to make 15 degrees. And here I'm going to choose 45 minus 30. Now you're going to know that you're on the right track if your two angles are both from the unit circle and if they add or subtract to make your given angle. There's probably going to be multiple correct answers. Here I'm just choosing the smallest that I can think of that will actually work to solve the problem. The next step, notice that the 45 is going to be alpha, the 30 is going to be beta, and then I'm going to apply the difference formula here. So that's going to give us tangent of 45 minus tangent of 30 all over 1 plus tangent 45 times tangent 30. And then once you've applied the formula, the next step is to substitute for each one of those trig functions what it's equal to. And this is where having a chart handy is going to come in, okay? So I do have a chart. We need tangent of 45, which we can see from the chart that's 1. And we also need tangent of 30, which is square root of 3 over 3. So tangent 45 is 1. Tangent of 30 is square root of 3 over 3. 1 plus, again, tangent 45 is 1. Tangent 30 is square root of 3 over 3. And then I've got to simplify this complex fraction. So if you ever wondered back in college algebra, why did I need to know how to deal with complex fractions? Well, here it is. This is a great time to practice that. So what I'm going to do is I'm going to multiply top and bottom by 3. That's legal. Whatever you do to the top, you have to do to the bottom. And the reason I chose 3 is because that's the common denominator for the numerator and the denominator, okay? So here we're going to distribute 3. That's going to give us 3 minus square root 3. In the denominator, if I distribute the 3, that's going to give us 3 plus square root of 3. Again, these 3's cancel here, leaving the radicals. Notice now that it's a fraction, but it's not a complex fraction because we don't have fractions in top and bottom. Now, this is still irrational. And so now what we're going to do is we're going to multiply the top and bottom by the conjugate. A lot of algebra going on here. So to remind you what the conjugate is, it's the denominator with a different sign. And remember, whatever I do at the top, I have to do at the bottom. So I'm going to multiply top and bottom by 3 minus square root 3. Again, that is the conjugate of the denominator. And this is going to require the FOIL method twice. All right, here we go. 3 times 3 is 9. On the outside, that's going to be minus 3 square root of 3. On the inside, another negative 3 square root of 3. Last but not least, that's going to be positive square root of 9, which will simplify to 3. Okay, I went ahead and wrote it like that as an intermediate step. Remember, when you multiply radicals, if they have the same radicand, if they have the same index, which a square root has an index of 2, then you can multiply the radicands together. And that takes care of the FOIL method for the numerator. Now we're going to FOIL the denominator. First, 3 times 3 is 9. On the outside, minus 3 square root of 3. On the inside, plus 3 square root of 3. Last but not least, negative square root of 9. And now we're going to simplify. And anybody that's thinking, hey, let's cancel those 9s out, you just need to slap yourself. That's violating the order of operations. You've got to simplify the numerator and the denominator and then look at reducing. All right, so the next step then, let's do it in purple. In the numerator, remember I said that square root of 9 is 3, and then 3 plus 9 is 12. So I'm going to go ahead and combine those like terms, and then I'm going to go and combine these like terms, negative 6 square root of 3. In the denominator, I've got a plus 3 square root of 3 and a minus 3 square root of 3. Those cancel. The square root of 9 is 3, and then I'm going to do 9 minus 3, which is 6. And then I'm going to factor a 6 out of the numerator. So that I can reduce the 6. And my final answer should be 2 minus square root of 3. That is simplified completely. And wouldn't it be nice if there was a way to check that? Well, it turns out that the Casio FX991EX Class Whiz does a great job. Okay, so the original problem was tangent of 15. As long as I'm in degree mode, if I hit equals, look at that. It gives the simplified radical answer and verifies all my work is correct. Man, isn't that a thing of beauty? Look at all those beautiful steps. Okay, let's do another example. And if you're wondering, this video is going to be kind of long because I got several examples here. Next, let's say that we have sine of 17 pi over 12. And the instructions say find the exact value, okay? So what you're going to need to do is you're going to need to come up with two angles. In this case, this is an improper fraction, so I'm going to choose addition. I need two angles that add to make 17 pi over 12, but those angles have to be from the unit circle, okay? So what I suggest you do is start with pi over 12 plus 16 pi over 12. Start with something that definitely adds to make 17 pi over 12. And then if those angles are not in the unit circle, then what you want to do is you want to increase one and decrease the other. Okay, here's what I mean. So obviously pi over 12 is not in the unit circle. So let's increase this by 1, 2 pi over 12. And let's decrease this by 1, 17, 16, 15. Okay, so check me. Does 2 pi over 12 plus 15 pi over 12 add to make 17 pi over 12? Yes. Now, 2/12 reduces to 1/6, which that is definitely a unit circle angle. And 15/12, 3 goes into both of those, so that would be 5 pi over 4. 5 pi over 4 is also a unit circle angle. So we could go with that right there. See, do you see it's not that hard and it doesn't take long to come up with two angles, both of which are in the unit circle, that in this case add to make our given angle. So we're going to go with sine of pi over 6 plus 5 pi over 4. And again, if you're not sure, you can bring up the handy dandy calculator and you can do pi over 6 plus 5 pi over 4. And do you see it does give me the 17 pi over 12 that I needed? So that verifies that these two angles will work. Are they the only two that are going to work? No. But these are two that do work. And now what we're going to do is we're going to say, okay, this is alpha, this is beta. Now I need to know the formula for sine of alpha plus beta. And this is where it really is nice to have these memorized, okay? So sine of alpha plus beta, that's going to be sine alpha cosine beta plus, notice for the sine sum and difference, for the signs are the same. So if it's alpha plus beta, you're going to still have a plus. If it's alpha minus beta, you're going to still have a minus. The cosine sum and difference are opposite. So if you have a plus, you get a minus. If you have a minus, you get a plus. All right, so we're focusing on the sine alpha plus beta, okay? So that's going to be sine alpha cosine beta, plus cosine alpha sine beta. So you apply the formula, and then we're going to go to our chart, unit circle chart that you should have handy, or maybe get a tattoo. That would be fantastic. And then we're going to look up sine of pi over 6. Remember, the sine is y, cosine is x in the unit circle, okay? Sine of pi over 6. Pi over 6 is 30 degrees. That's going to be a half. Sine is a half. Cosine is square root of 3 over 2. So this is going to be a half. This is going to be square root of 3 over 2. That takes care of both of our pi over 6. And then we're going to do 5 pi over 4. 5 pi over 4 right here is 225. The sine is negative square root of 2 over 2. Cosine negative square root of 2. Okay, so those are identical. So those are both negative square root of 2 over 2 for sine and cosine. And then we're going to just do the math, okay? So we're going to have negative square root of 2 over 4 minus square root of 6 over 4. Remember, you multiply the tops and the bottoms together. And when you multiply radicals together, you multiply their radicands. And then we can simplify this one more step, and we can say, let's say negative square root of 2 minus square root of 6 over 4, because those have a common denominator. And that should be the final answer, simplified completely, and that is rationalized. Let's check the calculator and see if it likes it. First, we have to go to radian mode. Type in sine of 17 pi over 6. I'm sorry, 17 pi over 12. And you're going to notice that the calculator answer is a little bit different than mine. Let me explain this. What the calculator did is it actually factored the negative out of the numerator and stuck it out in front. So when you have a negative in front of the fraction, that negative is meant to apply to both terms in the numerator. So either one of these answers is correct. They're identical. They're numerically equivalent, okay? And that's it for that example. I got several more examples, okay? Next problem. Let's say that we're given sine of 20 degrees, cosine of 10 degrees, plus cosine of 20 degrees sine of 10 degrees. And the instructions say find the exact value. Obviously, one thing you could do is just plug that all in the calculator, but if they want you to use a sum or difference formula, you're going to have to apply the correct formula, okay? So here's a couple of characteristics to look for. First of all, the sine and cosine alternate, and we do have a plus, okay? So this is going to be alpha and beta, and we just need to find the appropriate formula. So if we scroll up, we can see that for the sine sum and difference, the sine and cosine do alternate. Notice that for the cosine sum and difference, they don't. It's cosine, cosine, sine, sine for both of those. So we're going to be using a sine sum or difference formula. And since we're given a plus, it's going to be a plus. So this is going to be sine of alpha plus beta, 20 plus 10, which simplifies to sine of 30. And then at this point, super easy, if you have your chart handy, sine of 30, that's a half. And that's done. And if you don't have this chart, you can pull up your calculator and do sine of 30, making sure that you're in the right mode. And get a half. And you can even put in the original problem if you want to. Sine of 20 cosine of 10 plus cosine of 20 sine of 10. Half. All right, so there's multiple ways to get that problem. Of course, the calculator is very efficient, but if you need to show the work, they're showing the work using the sum and difference formula. All right, next problem. Let's say that we have tangent 20 plus tangent 25 all over 1 minus tangent 20 tangent 25. And here they're going to say find the exact value using a sum or difference formula. And so obviously it's going to be one of the tangent formulas where this is alpha and this is beta, and we have a plus up top and a minus in the bottom. So going back to our tangent identities, we have a plus up top and a minus in the bottom. That means that it's going to be tangent of alpha plus beta. So we're going to be using a sum formula. This is going to be tangent of alpha plus beta. Okay, so we're going to have tangent alpha plus beta, which is tangent of 45, which is 1. And if you need to go to the unit circle chart to look that up, tangent of 45 is 1, or if you just have that one memorized, fantastic. Or if you want to put this in the calculator, again, super easy. I'm not going to take time to show that again. More examples. Now, let's say that we have sine of pi over 12, cosine of 7 pi over 12, minus cosine of pi over 12, sine of 7 pi over 12. And again, they want us to find the exact value using a sum or difference formula. So from what we just talked about, we know that when the sine and cosine alternate, that this is going to be a sine formula. And if it's a minus in the middle, then that's going to be a minus in the sine formula. So now all we need to know is what is alpha and beta. So alpha is pi over 12, beta is 7 pi over 12. And then that's going to be sine of, and then you're going to have to know what is pi over 12 minus 7 pi over 12. Well, that's negative 6 pi over 12, which pi over 12 reduces to pi over 2. Also remember, when that angle is negative, you're going to have to use an even-odd property, okay? So the even-odd property for sine says that that negative comes out to the front and becomes negative sine of pi over 2, okay? So going to the chart, sine of pi over 2, pi over 2 is 90, that's 1. And so that's going to be negative 1. That would be our final answer, simplified completely. And I think I will take a minute to put this in the calculator and show that this makes it super easy. So again, going to radian mode, we're going to have sine of pi over 12 cosine of 7 pi over 12 minus cosine pi over 12 sine of 7 pi over 12. Fingers crossed. Bam! Man, it takes a little while to put in the calculator, I'll admit. But it also takes a little while to do the even-odd property and the sum and difference formula. Takes a little while. It's a trade-off, okay? But if you have to show your work, which you do on my tests, there's how you get that, okay? And I've got a few more examples, okay? Next example. Let's say that we have sine of pi over 2 plus theta. And we want to prove that this is equal to cosine theta. So this would be proving an identity using sum and difference formulas, okay? So here we're going to say this is alpha, this is beta, and we're going to apply the sine of alpha plus beta formula. So that's going to be sine alpha cosine beta plus cosine alpha sine beta. And then we're going to need to look up sine of pi over 2 and cosine of pi over 2 and plug in those values. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. 1 times cosine theta, that's cosine theta. 0 times anything is 0. And we have just established that identity using a sum or difference formula. Freaking sweet. All right, next problem. Let's say that we have sine of alpha plus beta all over sine alpha cosine beta. And here the instructions might say simplify completely. So in this case, we're going to apply a sum or difference formula. Here it's going to be a sum formula, sine of alpha plus beta. And that is sine alpha cosine beta plus cosine alpha sine beta all over the common denominator. And now since the numerator is 2 terms, I can actually split that up into 2 separate fractions, okay? Both over the common denominator, where the first fraction, the numerator and denominator are identical, so those will both cancel. Anything divided by itself is 1. And for the second fraction, I want you to notice that I've got cosine over sine of the same angle, sine over cosine of the same angle. So this is going to go back to applying identities we covered in the previous section, where we know that cosine over sine is cotangent and sine over cosine is tangent. And what we've just done is we've simplified this fraction now here, which this could also be establishing an identity, or this could be a trig proof. Either way, showing you how to implement the sum and difference formulas, okay? All right, in our next example, we're going to look at the sine of, the inverse sine of 3/5 minus the inverse cosine of -4/5. And here again, the instructions are going to say find the exact value of the expression. And I want to remind you that an inverse trig function produces an angle. So the inverse sine of 3/5, we could call that alpha, and the inverse cosine of -4/5 would be a different angle, call that beta. And then we can see that we got the sine of alpha minus beta, and we can apply the sum or difference formula. So for sine of alpha minus beta, that's going to be sine alpha cosine beta minus cosine alpha sine beta. And then the problem becomes, I now need to find 4 pieces of the puzzle so that I can plug in and solve, okay? All right, so now to break this down, we know that alpha is the inverse sine of 3/5. So if I bring the inverse sine to the other side, I can see that sine of alpha is 3/5. Remember that sine is y over r. And if I know y and r, I can get x. So we're now going to use Pythagorean theorem to find x. That's going to be x squared plus 3 squared equals 5 squared. Bringing the 3 squared over. 25 minus 9 is 16. Taking the square root of both sides, x is 4, okay? So let me explain what we've done here in orange, okay? Sine of alpha is 3/5. I can now find cosine of alpha, okay, based on this angle. Sine of alpha is 3/5, so cosine of alpha should be x over r, which would be 4/5. 4/5. There we go. And so now I can plug in for those 2 pieces of the puzzle. Right here, sine of alpha is 3/5. And cosine of alpha is 4/5. And now we're going to do the same thing for beta. Okay. So here we know that beta is the inverse cosine of -4/5. Bringing the inverse cosine over gives me cosine of beta is equal to -4/5. Again, cosine is x over r. And then I can plug into Pythagorean theorem and find y. So that's going to be -4 squared plus y squared equals 5 squared. And if you're wondering about this negative, it always goes with the numerator only. And so that's going to be 16 plus y squared equals 25. Bringing the 16 over gives me y squared is 9. And taking the square root gives me y is 3. So now look what I know. I now know cosine of beta, which is right here. Cosine of beta is negative 4/5. And now I can get sine of beta. Sine of beta, sine is y over r. So sine of beta is 3/5. And now I can find the exact value. Multiplying these fractions together, that's going to give me negative 12/25 minus 12/25 is going to give me negative 24/25. And so now I've calculated the value of the original problem as an exact value, using the sum or difference formulas, also using the inverse trigonometric identities there, okay? Got another example for you. Let's say we have the cosine of the inverse cosine of u plus the inverse sine of v. And we want to work this out as an algebraic expression. We want to convert from a trigonometric expression to an algebraic expression. So remember that an inverse trig function produces an angle. So we could say that this is alpha, and we can say this is beta. And then at this point, we can say, okay, alpha is the inverse cosine of u. Bringing that over will give me the cosine of alpha is u, which I can make that into a fraction by putting it over 1. Cosine is x over r. And if I know x and r, I can get y. Okay, so using Pythagorean theorem, x squared plus y squared equals r squared is going to be u squared plus y squared equals 1 squared. And then I'm trying to solve this for y. So y squared is 1 minus u squared, taking the square root of both sides, gives me y is the square root of 1 minus u squared, okay? So now I can find sine of alpha. Remember, sine is y over r, which would be the square root of 1 minus u squared over 1, which would be the square root of 1 minus u squared. So there's sine of alpha. And remember, cosine of alpha was u. Now then, for beta, we know that beta is the inverse sine of v. Bringing the inverse sine over makes it sine of beta equals v. And then if I make that into a fraction, I know that sine is y over r. And now I can find x. So x squared plus y squared equals r squared. Solving for x, that's going to give me x squared equals 1 minus v squared. And taking the square root of both sides gives me x is square root of 1 minus v squared. And so now I can find cosine of beta, because cosine is x over r, which would be the square root of 1 minus v squared over 1, which is the square root of 1 minus v squared. Okay, so now I have the cosine of beta, and remember the sine of beta was v. So now I've got all the pieces of the puzzle. Now I'm going to apply the sum formula for cosine, okay? So the sum formula for cosine is cosine alpha cosine beta minus sine alpha sine beta. And if you need to, remember you can scroll back up and check those. Again here, cosine alpha plus beta. See, the plus turns into a minus, and you've got your cosines and then your sines, just like we have here. And now it's time to do a little plug and play. Okay, cosine alpha was u, and cosine of beta was the square root of 1 minus v squared. Minus the sine of alpha was the square root of 1 minus u squared. And the sine of beta was v. And believe it or not, that's about as simplified as that's going to get. I think that if I was to do anything, I would rewrite it as u square root of 1 minus v squared minus v square root of 1 minus u squared. And there's that expression now as an algebraic expression. And for my last example, for this section, we're going to look at solving a trigonometric equation in terms of sine and cosine. And so let's say that we have this equation. We have sine theta plus cosine theta equals square root of 2. And we want to solve for theta. And so what I'm going to do first is it's going to look like, what are you doing? But stick with me. It'll make sense as we go, okay? Remember that I can multiply both sides of an equation by the same value. So what I'm going to do is I'm going to multiply both sides by 1 over the square root of 2. And then this is going to distribute here, okay? Now it should make sense on the right-hand side, because if I multiply something by its reciprocal, that's going to be 1. So I know this is going to work out to be 1. And on the other side, I'm going to rationalize the denominator. So instead of 1 over square root of 2, if I rationalize that, that would be square root of 2 over 2 times sine theta plus square root of 2 over 2 cosine theta. And that's the part that you may go, that makes no sense. That made that more complicated. That didn't simplify it. On the right-hand side, it simplifies to just 1. And now we're going to go back and we're going to ask ourselves, okay, I've seen this before. Square root of 2 over 2. I have seen that before, okay? So what I think that is, I think that's cosine of pi over 4 and sine of pi over 4 is what I think that is. Let's see here. So let's say that this is cosine of pi over 4, and this one gets replaced with sine of pi over 4. Because at 45 degrees, which is pi over 4, the x and the y coordinate are both square root of 2 over 2. So then I can make these substitutions because those are equivalent. And now what I'm hoping you're going to notice is that we have a sum or difference formula, okay? So if I rewrite this, knowing that multiplication is commutative, and I can switch these around, that's going to say sine of theta cosine of pi over 4 plus cosine of theta sine of pi over 4. And that's going to be the sum or difference formula for sine. Okay, where this is alpha and this is beta. So for the sine, if it's a plus, it stays a plus. That's going to be sine of alpha plus beta equals 1. I've just applied the sum or difference formula for sine alpha plus beta. That's sine alpha cosine beta plus cosine alpha sine beta. And then what I can do is I can say, okay, remember that sine in the unit circle is really y. And what angle has a y coordinate of 1? Well, that's pi over 4, okay? So I know that this is going to be pi over 4 pi over 2. The y coordinate at pi over 2 is 1. So I know that this angle, whatever it is going to have to equal to pi over 2. And then I can finish solving for theta. Bringing that over makes it minus pi over 4. And pi over 2 minus pi over 4, a half minus a fourth is a fourth. And then that's going to be the angle that solves the original equation, okay? And if I want to, I can plug that back in and check it, which I think I'm going to do, okay? So let's see, sine of pi over 4 plus cosine of pi over 4, does that really equal square root of 2? Well, sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is also square root of 2 over 2. And since those fractions have a common denominator, I can add those and get 2 square root of 2 over 2. And then these 2's will cancel, and it checks out. And so they're solving what we would refer to as a linear equation in terms of sine and cosine. And that's going to do it for this lesson. Okay, so if you have any questions or comments about anything I've covered, feel free to leave those in the comment section below, or you can text me. And thanks for watching.